Well, welcome to another Lightblade Learning Lab. Today, the title of the piece tells it all. We're going to use some of this A4 Baltic birch plywood, which is 3mm thick, to try and make some puzzles. Now, jigsaw puzzles are, on the surface of it, quite simple to make once you've got the design sorted out. But manufacturing it so that it's a really nice, neat piece of work is much more difficult. So today I'm going to show you, first of all, the problems that we're going to have, and then we're going to try and find a solution. Now I say try and find a solution because I've not done this before, and so we're going to jump into something very new, which I'm moderately confident will solve the problem. Now let's forget the details of the puzzle itself at the moment and look at the physical problems that we're going to face. I don't think that's necessarily a good idea to use this table to cut this puzzle on, because first of all the pieces will fall down inside, some of them will get trapped in here, and as they get trapped in here, what will happen is the cut, as it carries on, will mark the pieces that are trapped in here. You know, you've just got no control of where the pieces are going to fall. That tells us that before we start, we've got to retain the puzzle in one flat plane, complete, while it's being cut. So that leaves us with this second option, which is the honeycomb table. When you're cutting wood, you can see what happens on here. Look, we've got all sorts of brown muck in here, which when we pass the laser beam over the top of it, it's going to blow up horrible fumes at the back and mark the back of the job. So let's just test this as an idea to start with. Right, well, I've got a 2-inch lens in here. Here's the material that we're going to be using. It's a nice white Baltic birch plywood. I've got a 2-inch gallium arsenide lens in here, which will be one of the standard lenses that you're supplied with. And I'm just going to run a test square up in this corner. I'm running at about 25mm a second on full power. And I think, as you can clearly see, we've got all these marks around the pieces, which is where the laser beam has jumped over these small pieces of honeycomb. Although this solves one problem, i.e. it keeps all the pieces in one plane and together, if you're happy to accept this on the back of your puzzle because it's only for your own use, then go ahead, use your honeycomb table. But to me, that's totally unprofessional and the wrong approach. If you're trying to sell bespoke puzzles, for example, to somebody, you certainly won't want all these marks on the back of your pieces. Very unprofessional. So, we need to start looking for something as an alternative backing material. My first reaction was, hey, let's have something that doesn't cause smoke. Something that won't burn. And here we are. Look, we've got a piece of polished granite. Now, this doesn't burn. We won't get any blowback off the surface. So I'm going to leave the extraction off so that we can see what happens. Not huge amounts of smoke. There's a good reason for that. Although it's a lovely, nice, clean cut on the top, as you can see. Let's take a look underneath. Well, the reason why we didn't have too much smoke coming upwards was because it all went downwards. We've managed to damage the surface here, but look, we've got all sorts of sticky brown stuff on it, which is the fumes that have actually vaporized on this cold surface as they've been blown through the job. And look, those same fumes, which are in a liquid sticky form, have also done a huge amount of damage around the outside of our cut. So very, very, very unsatisfactory. So that's not a solution to our problem. We've got to find a way of getting the fumes cleanly out the bottom of the job so that they can get extracted away and we don't get any reflections off of pieces of material that are supporting the job. That sounds like an almost impossible task when it comes to cutting jigsaw puzzles, which are a whole load of separate pieces. You know, we need sky hooks to hang them on, and I'm afraid I don't know how to make sky hooks, but I am going to have a go at trying to make something which is a close alternative to a sky hook. Now here we've got a construction that basically is made up of two small pieces, base plate and a top plate. I'm going to assemble this onto this top plate rather than onto the base plate. So speed is of the essence while we're doing this part. Okay, so here's our assembly. If we look through it, we shall see that we've got a clear passageway underneath here for the air to flow through underneath this plate. And as expected, it's a nice snug fit for our piece of plywood. We've got a solid surface behind here, so we're going to produce exactly the same effect that we did here if we're not careful. We're going to get debris which condenses on this surface and runs out behind the cut. We need to make sure that the fumes that we produce during cutting go right the way through the job, and then we can put air underneath here, remember, where it's a nice clear passageway, and get sucked away. So somehow we're going to have to pre-cut this in the shape of the puzzle so that the track, when we cut the puzzle, the fumes pass right the way through here. To do that means that we've really got to bolt this fixture down onto the table, which is nice and solid, so that once we've cut a track in here, we can immediately replicate that when we come to cut the puzzle. We don't want the puzzle to be cut over a different track than the cuts that we've produced in here. Now, to do that, we can't rely on any external location. So we're going to have to use a feature that's available on this machine, a feature called absolute mode. And let me explain what absolute mode is for those of you that have never used it before. Well, here I've drawn a sheet of A4 size material, and across the centre line here I've drawn two holes, just here and here. Now these are going to be the fixing holes that I used on my jig. I'm going to have to put these holes into the base plate of my machine, so that whenever I put this jig back into the machine, I will know exactly where the coordinates, where the program is going to run, because I have changed this feature here called position from current to something called absolute coordinates. Now what that means is you will not be able to use the origin button on your machine. So what I'm going to have to do eventually is to draw our puzzle picture on top of this template, because this is a template that is going to allow me to always replicate exactly the position of this piece of A4 material, and my program will always work with exactly the same coordinates that I've programmed and run in this machine. So if I set my piece of material at the top here, it will always run up here. So positioning of this is not super important. It's conveniently wherever you want it on your machine bed. I've dropped mine here, and that's where it will be forever when I use absolute coordinates. So that means that you must save this picture here as an RLD file, because this is going to become a template for any other program that you want to run on A4 material in this jig, or another jig that you might want to design around the same fixing holes. So once we've got the fixing holes in the machine, we've effectively got a new reference position which we can replicate every time. I'm going to find a way to put these holes into my machine bed exactly where I've drawn them. And to do that, what I'm going to do is to put the holes on a different layer. So let's put them onto a red layer. Okay, so we'll now come up to the top here, and we'll set the red layer to cut some holes. 7mm, yeah. Polish power, yes, that'll do. So it's a cut layer. Okay, now the black layer, we'll check the black layer, and it says here, do you want an output? Well, the answer is no, and it doesn't matter what any of the other settings are now. So these spacings here are roughly 50 millimeters apart on this grid. So 1, 2, 3, it's just over 150 millimeters, about 160 millimeters up from the bottom edge of the table. I've got a strip of material here, acrylic. It doesn't matter what it is. This happens to be about 5 millimeters thick. So roughly 160 millimeters up from the bottom edge of the table. We'll set that across there like that. Put a little bit of tension on it. Just to make sure that piece of plastic is not going to move. And there we go, that's pretty solid. Now, as you can see, the table has got a small amount of movement in it this way, but I purposely made it so that it's got nothing in it sideways. But what we can do is to remove the clearance in the table backwards and forwards with that small peg. So now we've got a completely solid table, no movement. So we need to just set the focus correctly. When I run this program, all I'm going to do is going to get 2 holes punched through the material just there. Simple as that. Except I've now got to get these little pieces out. Click. We'll now remove our cutting template. And I've got an M4 tap here. Now hopefully I've got nothing underneath there to get in the way of my screws. I'll just check. I can now screw my fixture down to the table with 2 screws, and I know exactly where my sheet of A4 material is going to be relative to the 00 of the machine. And whenever I run this program, it will always be in exactly the same place. Now obviously you can't do it if you've got one of these floating around, and it only works if you can get an absolutely stable base to bolt it to. We're going to create our own picture. Trains, country cottage. Nobody's going to complain about a lovely lady like that, are they? So we know exactly where this A4 sheet is, and any pattern that we draw on it will be, the program will be referenced to 00 in the corner there. Now this is everything that you want to know about the A4 puzzle on one sheet of paper. So we need to zoom out and you'll see what I mean. So here we've got the jig, which we don't need. Delete. Here we've got my basic general arrangement, which we don't need, and we will delete. Here we've got a layout of what the top plate looks like with all the little reference squares in it, so it's just a check. Delete. Here we've got the puzzle pattern, which we don't need at the moment, so we delete that, and the only thing we're left with is this jig preparation template. Now I'm going to leave the 2 holes in because everything is symmetrical. I'm going to mark that and make that a group. I know that I've put the puzzle symmetrically in this A4 frame. I'm going to mark just the puzzle and not the frame. I'm going to put it into a group, click on that, and we'll turn that into a blue layer. I'm going to put handles on that blue layer now, and we are going to press the Shift key, and we're also going to highlight this other group, and I can now use these alignment tools at the top here to align it first of all horizontally, and watch this jiggle. There we go. So it's now jiggled out of line to its own reference square, but that doesn't matter because what we're doing, we're lining the pattern up with this reference square. We've put our pre-cutting template into the correct position on the jig. we can now delete this frame here because we don't need it. We've got everything that we need just here. We don't want anything black to cut, so we'll check the black layer and we'll make sure that it says is output no. Okay, we'll now check the parameters for the blue layer. Is output yes. Speed 20 millimeters a second, that's good. Blowing yes. Cut yes. And power 80%, that's good. Okay. Now we need to make sure, just to be doubly sure, the last thing you check is that you've got absolute coordinates set down the corner here. Now we've set the focus up already to 6.5 millimeters reference to this surface here. Okay, so I've removed all the pieces and you can see what we've got there. We've got a 2mm gap between every single piece, and I hope that's going to be enough of a gap to let all the smoke out the bottom of the job without coating the bottom of the job with this horrible brown gunk that we get by any other means that we can try and produce this puzzle. Right, so we've got our fixture bolted back in the machine. We know it's the right way round because I put some location reference marks at the back corner there to make sure that we didn't get it in the wrong way round, because although the jig is symmetrical, the pattern in the puzzle is not, and it only works this way round. We've got our lovely lady that we can cut. I have got an alternative for those that like aeroplanes. When we engraved this, it tended to curve this way. Now I would have liked to have put it in the jig that way, but it meant that the middle would be standing up and slightly out of focus. Now this is a really snug fit in here, which is great. Although it's dished, we've pulled the corners down so it's all back to flat again. Now we must remember to set the focus to a different position this time. So 6.5. So we've got lots of smoke coming out underneath, which is good. As I mentioned right at the beginning of this video, cutting the puzzle is the easy part. It's preparing to cut the puzzle that's the difficult part. Now at this moment in time, we've got all the pieces suspended by their ends. It's only when we start on the next phase, which is the cross-cutting here, that all of a sudden the pieces start releasing stress. Well, we don't at the moment seem to have come across any inclusions or voids within the material. If we did, they would have produced some probably horrible black marks on the surface. Now this puzzle may only be 140 pieces, but my guess is, because all the pieces are square, there's one piece of clue, there is one clue that you haven't got, which is basically some of the shapes of the material. The other thing is all this stuff is shades of brown, which makes it very difficult to match up. So I suspect this is going to take somebody quite a long time to rebuild this puzzle. With a piece of clear perspex underneath, I'll slide the whole puzzle out. And the reason I've slid this out onto a piece of A4 clear perspex is so that I can turn it over and we can have a look at the back. Well, I have to say that it's not entirely successful. Look, round each knob we've got a little pocket of gas which has been trapped because we haven't got a clear passage for our smoke to exit below the cut. So unless we can find a solution for that, which means cutting away big chunks in lots of places, we probably would do just as well to do it on the honeycomb table. And again, it's curled up at the corners, but not badly. But what we'll do, we'll put half a dozen magnets reasonably flat. And there's not a lot of grip on honeycomb. Now again, all we need to do is to measure roughly 150 millimeters in there, and that's where we're going to start. Now we've covered the honeycomb with as much paper as we can to try and block off the airflow going down that way, hopefully what we're trying to do is to get as much airflow pulled through the cuts as we possibly can. 6.5 mil. So, from the front side, that looks a half decent puzzle picture. Let's have a look, see what it looks like from the back. Well, I suppose you could always spray it white, couldn't you? And that's the reason why we started this whole project off saying it's going to be very, very difficult to get the back of these puzzles clean. Now, I'm afraid it's a bit sad to say, but I think there's only one place for this. And that's in the bin. Now, this was the only one that gave anything like half decent results. And as I said, where we had a clean run across the job, we got virtually no marking. And it was only when we went across this way that we had marks. And it was mainly on the, well, it was literally only caused by these tongues. Now, what that means is you could possibly solve this problem by making two fixtures. One with braces that run across this way and one with braces that run across that way. So you do half the puzzle like this, and then you do the other half of the puzzle in the second jig like that. Now, if you're that enthusiastic about making decent quality puzzles, then there is a solution. I'm not going to do it because I've proved half the problem has been resolved, and I can see what the other half, how the other half could be resolved. But that still leaves us with the problem. The cuts are a significant part of the picture. They are predominating. This may well be a lot less dominating if we were to do this with a coloured photograph, because it would take your eye away more from these marks. So perhaps I'll have one more try at trying to create a nice puzzle. And I think there's a possibility that we might be able to do it. Here we are with a photographic print, and what I've got here are two things. First of all, I've got some special double-sided very high bond strength tape by 3M, and you can see it's called 3M 476MP. Now, you can buy this in sheets. It's pretty expensive because it's a very thin film adhesive, and it's an acrylic adhesive that cuts very well. Now, we've got to apply this to the back of the picture, and we'll do that by peeling off the front clear plastic. Now, we'll fold it over like this, so that what we can do, that holds that end off while we fit this end nicely. I've cut this already to A4 size, and I know that it fits perfectly onto A4, and now I should be able to just wipe that up there like that and stick that onto the top. And now, to make sure that I don't get bubbles under it, what I'm going to do is gradually pull this piece off from underneath here like this, while at the same time I'm running my finger backwards and forwards along here to make sure that we push all the air out as we go. Now, what I've got here is a piece of acrylic, 3mm thick. This happens to be a piece of frosted acrylic. Now, acrylic is not going to cause as many fumes as wood. We've got to get the backing tape off of here, and again we'll do the same thing. We'll fold that over so that we can line everything up approximately, and this time I'm going to use some clean kitchen towels so that I don't damage the gloss on the paper. We're going to cover the honeycomb again with paper so that we get plenty of extraction straight through the cut. And again, we're going to set our datum down in the middle here. Set the origin because we're in current mode, remember. Now black lines across a coloured photograph will actually be less distracting than those black lines across a brown image. Now we've got full air assist on, and I'm trying to extract as much air as I can out the back, because it's absolutely essential that we don't get any white debris up on top of our job. All the smoke must go out the back of the job. And now comes the tricky bit, getting it off the table. Look at the muck that's on the top there. Oh my goodness me, look at the dust that's come up. But it does wipe off easily. And surprisingly enough, it has not damaged the picture. Just keep wiping it until the tissue goes clean. Okay, so we've jiggled it now onto a piece of paper. Let's see what it's like on the back, shall we? Well, I would say that that's almost presentable on the back there. Well, in this session I hope that I've steered you away from all the possible pitfalls of making a wooden puzzle. Now, a wooden puzzle is something that really is reserved for a clean machine like a jigsaw, which is why it's called a jigsaw puzzle. Laser cutting is not a very good process for working with wood or cardboard, because we produce far too many fumes which will condense and damage your pieces. What we have finally shown you is the way in which you can succeed by producing a really nice contrasty colour picture which takes your eye away from the black lines that are on here. You have to do it from the front, so you need to make sure that you get your parameters set up well. Although we have got some black marks on the back here in a few places, those black marks would not show at all if you change this material from either clear or frosted acrylic, as I've got it there, into a satin finished black. Now put the satin finish face down on the honeycomb table and you will probably hide any marks that happened to be on the back here. So now you have the secret to making personalised puzzles, and I will pass this puzzle program onto Thinklaser so that you can download it for yourself. Well, thanks again for your time, and I'll see you in another session.